Aloha kako. Welcome back to the Neb Hapakahana Online Professional Development for our 7th grade curriculum. Let's take care of the lo'i. In this video, we'll be covering Unit 6, Probability. Here are the Common Core standards that will be covered in this unit. Please feel free to pause this video if you would like to read them more thoroughly. If you have a copy of our curriculum, you'll be able to find all of these standards at the very beginning of the unit. The standards in this unit are from the Common Core domain of Statistics and Probability, as denoted by the letters SP. In the previous unit, there was a focus on the statistics standards in this domain, but this time there will be a focus on the probability standards. These standards mainly focus on how to quantify random events. First, we need to understand that the probability of an event is a number that ranges from 0 to 1, where an event is less likely as the probability gets close to 0 and more likely as the probability gets close to 1. On a side note, there is a bit of a technical nuance here. We are often taught that when an event has a probability 0, then it means that it is impossible to happen. In many cases though, that is actually not true. For example, if I were to ask someone to choose a positive integer, what would the probability of choosing the number 7 be? Technically, the probability can be calculated to be 0 because there is an infinite number of possible numbers to choose from. However, the idea that it is simply impossible for someone to have chosen the number 7 would be absurd, because it is totally possible to have chosen that number. You can also make the same argument for probability 1. The probability that someone chose a number other than 7 would be 1, again, because there is an infinite amount of numbers to choose from. Yet it is still possible to choose a 7. Okay, so let's get back to the standards of Unit 6. The next area of focus is on theoretical and experimental probabilities. In particular, we will have to consider observed outcomes and their probabilities. We want to be able to look at the frequencies of some long-run outcomes and calculate the underlying probabilities. And we also want to be able to look at the probabilities and predict long-run outcomes. To find these probabilities, we often have to develop and make use of models or generate and collect data. And when we have both the model and its data, we are able to compare the two to make sense of the chance event. When we are dealing with compound events, we often have to make use of additional tools such as simulations, organized lists, tables, and tree diagrams. The Unit 6 activity that we'll be covering in this video is the Module 13 Theoretical Probability and Simulations activity. In this activity, we are looking at a popular plant in Hawaii called the awa, which is more commonly referred to by its Tongan name, the kava. The kava is used to make a bitter drink that is really popular in ceremonies and parties. And while it's really well liked in Hawaii, it has an evil twin known as the false kava. Unlike real kava, the false kava is highly invasive and grows aggressively in the wild, often covering large areas and smothering native plants. In this activity, we have 2 nature experts and 10 student volunteers looking to pull out some invasive false kava from some areas in Na'ahiku, Maui. The 5 different areas are shown here as Area A to Area E, where each T represents a true kava and each F represents a false kava. In part 1 of this activity, we need to calculate the probability of randomly choosing a false kava in each of the 5 areas. Please pause the video and calculate the 5 probabilities as a simplified fraction. Please note that each area has a total of 16 plants. Welcome back. So in Area A, we have no false kava, so the probability is 0. In Area B, 3 of the 16 kava are false kava, so the probability is 3 over 16. The probability for Area C is 12 over 16, which simplifies to 3 over 4. Area D has a probability of 14 over 16 and simplifies to 7 over 8. And finally, Area E has a probability of 1/2. In part 2 of the activity, we have to answer more questions about the plant areas. We're just going to do part 2b together and move on to part 3 of the activity. In part 2b, we are asked to find the probability of choosing an area that does not have any false kava. Well, the only area that doesn't have any false kava is area A. So we have one area out of the possible 5 areas, so our probability is 1 over 5, or 0.2. In part 3 of this activity, we have to designate the 2 nature experts and the 10 student volunteers to each of the areas. The experts can tell the kava and the false kava apart, so as long as there is at least one expert in an area, no true kava will be accidentally harmed. The volunteers, on the other hand, can't tell the difference and will randomly guess whether or not to pull the plant if there are no experts with them. Please pause the video and think about how you would assign these people to different areas. Please also take the time to justify how you would split the groups up. Okie dokie, welcome back. So this is a pretty open-ended question. It's okay to have different answers, but what is most important is the underlying justification. For example, there are no false kava in area A, so maybe we don't need to send anyone there. For the areas with a lot of true kava, perhaps we need experts there to protect them. Or maybe you want to send the experts to where there are just a few true kava because you don't want the volunteers to get carried away in those areas. We always support modifying our activities to fit the needs of your classroom or your teaching style. In particular, we think compound probabilities are usually difficult for students to understand. So we suggest perhaps spending more time in part 2 of the activity and providing more practice questions similar to part 2c. Here, the students can explore different ways to do the calculations. For example, instead of multiplying the probability of choosing area C with the probability of a false kava in that area, you can also count the number of false kava in area C and divide that by the total kava in all 5 areas. It is mathematically the same. We also find that a lot of people are not aware that there is such a thing as false kava. When people see it, most people think that it is the real thing. We think it would be a great project to catalog other plants and animals that are very different but commonly mistaken for one another. The students can use the internet or collaborate with experts, and then they can bring their findings together and share the new knowledge. Mahalo nui for joining us as we go over the Let's Take Care of the Lo'i 7th grade curriculum. We hope that you've enjoyed our activities, and we wish you the best of luck in your classroom. Ma'alama pono.